So in this video, we are going to take a look at some examples for finding domain. As a reminder, let's look through some of the rules about finding domain, where we start and how we start with these things. With number one, we want to start with all real numbers. We look at the number line, look at all real numbers, all right, and then we're going to reduce that domain in some of the problems. The first thing we're going to look at is to eliminate any inputs that lead to division by zero. When you divide by zero, it gives us an undefined answer. So we have to look and see where our functions are divided by zero, and we get rid of those inputs that lead to division by zero. After that, we look at any inputs that lead to non-real answers. So for right now, we're looking at the inputs that are going to be negative under square root signs. So we'll look for that. And then finally, one more thing is in many real-life problems, negative numbers don't really work for measurements. For example, maybe you're trying to find the domain of the diameter of a circle. And so you have to be really careful with that because you can't have negative values as a diameter for that circle. So just keep that in mind as you're looking through some of the functions and some of the story problems that you'll do in the homework. The first example we're going to look at is finding the domain of the function f of x equals the square root of x minus 5. We start with all real numbers, and then we look for anything that's going to lead to division by zero. In this function, there's no division. There's just a straight square root. So we can just bypass the division by zero because there's going to be no division by zero no matter what the input's going to be. We then move forward to inputs that lead to non-real answers. And this is the one that's going to limit our domain a little bit. So we have to determine what values for x inside here are going to lead to non-real answers. And non-real answers are going to come from negative underneath the square root. So what we're really looking at is we're looking at values where x minus 5 has to be greater than or equal to 0. We want it to be greater than or equal to 0 because we can take the square root of 0 and we can take the square root of anything bigger than 0. Anything less than that is going to lead to non-real answers. So in solving this inequality, we're going to add 5 to both sides, and we end up with x is greater than or equal to 5. So any values 5 and greater than 5 are going to work for this function, and any values less than that are going to break our machine or function by giving us non-real answers. So when we write our domain, we can write it in inequality notation like this, or you could also write in interval notation like that. And in my class, we're most primarily going to use interval notation, but this isn't wrong either, so keep that in mind. All right, let's move on to a second problem here. And we'll start with the function f of x equals square root of 3x plus 15 divided by x minus 3 times x plus 2. And we'll look at this function to see if we can determine what the domain is of this function. So again, we start with all real numbers, and we're going to eliminate some going from there. So we'll look first at leading to division by 0. And we're trying to see what values are inputted for x that will give us 0. In the denominator. And so we have a couple things in the denominator here. And if either of these parentheses are 0, that's going to lead to division by 0. So what we're looking for is we want to make sure that x minus 3 is not 0, and we want to make sure that x plus 2 is not 0. Because if either of those are 0, it'll lead to an undefined answer. Solving each of them individually, we get x does not equal 3 and x does not equal negative 2. So those are values that we're going to eliminate from our domain. Next, we're going to look at eliminating non-real answers. So we do have a square root in this function as well. So we have to make sure that that square root always stays positive. So just like the problem before, what we're going to do is we're going to take our 3x plus 15, and we want it to be greater than or equal to 0. Same process, we're going to solve for x in this inequality. And move that up. divide by 3. And we x is greater than or equal to -5. So now we've got to put it all together. We've got a couple of pieces here, and putting those pieces together is what we want to do. One thing that makes it a little bit easier on me is to first put it on a number line. And here are all my important points here. I know that we have -5, and x has to be greater than or equal to that. So bracket that, and we want to be greater than or equal to that, but we know that we can't be -2, and we cannot be 3, because those lead to division by 0. So what we do is we leave an open circle at 2, we leave an open circle at 3, and we have the rest of this function. So in writing our domain, here's where it's going to be a little bit easier to write it in interval notation. Starting at -5, including -5, we want to go all the way to -2, but not include -2. We join that with -2 to 3, including neither of those, and then we join that with 3 to infinity. So what this is really saying is we're using all numbers from -5 to -2, excluding -2, because that's going to lead to division by 0, and then -2 to 3, excluding 3, because that's going to lead to division by 0 again, and then 3 all the way to infinity. Anything less than -5 leads to non-real answers, and then these two values lead to division by 0. So we're going to go through one more here. And this problem is going to be